Hi everyone, and welcome to my talk Going Fast and Cheap with both Sanity and Kubernetes. My name is Olav Nybø. I'm a senior consultant and partner in Novanet. For the last couple of years, I have worked for Thon Hotels, and some of the technology I'm talking about here today are things we are using in their systems. On my spare time, I love playing games and MMO games in particular. For quite some time now, I've been playing World of Warcraft Classic. This talk is not about the game, of course, but I will use a tool I made for my guild as an example to show how we can use some, in my opinion, pretty cool technology to go really fast. When developing this tool, I did not want to spend too much time on the coding. I wanted to go fast. And being a hobby project, it had to be cheap. And I selected Discord, a voice and chat application for the UI, implementing a text-based chatbot. Kubernetes to run the bot, and finally, for the data, I chose the headless CMS Sanity. But to set the stage and make sure you all understand what I'm building, a few words about what World of Warcraft is all about. You create a character, then you enter a huge world and play the game for a very, very long time to level up your character and to make it stronger. And finally, you will reach max level and you are ready to start for what for many is the real game, which is raiding. Raiding is an activity where 40 players venture into some specific area of the game where there are particular hard monsters that the 40 players need to cooperate and coordinate carefully to be able to successfully defeat. Raiding in World of Warcraft Classic is a lot about organizing. That is making these 40 people work together. Voice communication is considered a necessity to be able to make this coordination happen. That is, we need to be able to speak to each other to communicate fast and well enough. A headset with a microphone and Discord, a voice and text chat application, not too different from Slack or Teams, is very commonly used when raiding. To be able to routinely gather 40 people to do these raids, most players join other players in guilds. And this is another area where the need for organization comes in. There are typically more than 100 players in such a guild. Each of these players can learn different professions. A profession gives the player the ability to make things that can be essential for raiding. One example of such a profession is alchemy, the ability to make potions and elixirs that are really useful in raids. To be successful as a group, it is really helpful to have knowledge of what resources are available to the guild. What can the different players do? So I wanted to make a tool where I could ask, do we have someone to make this and that potion? Who are they? And then I can ask them to help me out. So what I needed was a simple UI where the gamers can search for crafters of recipes. To make this happen, I needed somewhere to store the data, and I would also need a UI for entering and editing of the same data. Finally, I would need somewhere to run this, some sort of platform. My experiences from building this system and my choices for those 3 building blocks is what this talk is about. Let's start with the data, as this will help explain the requirements better. I didn't opt for a regular database for this. In fact, my selected tool was Sanity CMS. Sanity is a headless CMS system, and in my opinion, a wonderful product. Being a CMS, it may not be built to serve as a database, but it has a strong emphasis on the data model of your content, and as we shall see, it automatically provides a very nice user interface for interacting with the data as soon as we have the model in place. To get started, you simply use npm install, as shown here, to install the Sanity CLI tools. And then you do a Sanity init, and we get a starter project that will produce something similar to this. Here we can see the Sanity Studio, which is the tool that we build to both to interact with our data in the database. Here we can see I have defined my different document types. I have players, that's the people or persons that are part of my guild. And each of these players, they can then have one or more tunes. That's the characters that they are playing with inside the game. If we look at one of these documents or one of these tunes, we can see it has different fields of various types. I have text fields, and I have here a back reference, a reference to another document, to the owner or to the player of the owning this tune. We have switch controls for Boolean values, and we have drop-down lists, which is really implemented as strings with some constraints, as we shall see. And here we have a list of recipes for that tunes, the recipes that he can make. And this is then a one-to-many relationship in our database. Even if Sanity is kind of like a document database, we can model one-to-many relationships between the different document types. And the recipes itself can be seen down here with another set of fields. This tool is then deployed to the Sanity servers using simply on the command line sanity deploy. That's all there's to it. And we then get this user interface hosted at the Sanity servers. But while we are developing the tool and at the same time developing our data model, we will run the same user interface locally on our own machine. So here I'm on localhost, and I have, if you noticed, I have removed the recipe, and I will use that as an example to show you how easy it is to add something to the user interface here. So let's look at the code. This is what you get when you do that initial npm init. The most interesting part is this schemas folder, where we have the root document, the schemas, defining the start of our database model. It is developed in regular JavaScript. Mostly we define different objects that will then define our database model. So my types here from the create schema function, we list the different types of my database. So I have players, tunes, and some other types, and then finally the recipe that I have commented out here, just to show you how this works. So I add the recipe back, and we can see here we used standard JavaScript import statements to import the different schemas for the documents into our main schema. Let me save this. And we can see here on the recipe how we define a recipe. I export it as the default for this module and give it a name and list it as a document type. I can here add an icon. Just use any regular icon library. In this case, I'm using React icons and game icons to get this scroll icon that we can see in the user interface afterwards. And then we list all the fields of the document, and again we just use simple JavaScript object declarations to list the different fields. So we have a name with the type string, we have a profession, and that was the drop-down list that we saw earlier, and this is then constrained to the different allowed or the different professions that are available in World of Warcraft. So we have alchemy, enchanting, and so on. And we can have number fields and Boolean fields and all the types that you would expect in a database. We saw that we had a reference from the tune to a list of recipes. So I will also go in here in the tune definition and then add an array of recipes, or an array actually of references to another document type, which is the recipe document type. So this is simply how we then add something to our model. We can then go back here. I didn't show that maybe. I have started here in my terminal. I have started the Sanity local web server using just Sanity start. It will then compile my files and immediately watch, and I will also watch for any changes that I do to my schema, and immediately update here the running user interface. To see this in action, we can go into a recipe here, and here we see I have intentionally made an error. I don't want the field name to be nodes 1, 2, 3. So let's go in and change that. Find the recipe and find the notes field, and here we have the title 1, 2, 3. And if you look carefully down here, you will see when I save this, it will start rebuilding. Down there it starts compiling, and we can also see that the user interface here is rebuilding and automatically updating. So all of this gives us a very nice experience developing both the user interface here and the model at the same time. We can do customizations also. It's very flexible, the tool. We can, if we look, the default presentation of a list of documents is like this, where we just list the document name, the main field. But if we want something different, we can easily configure a different presentation of the document types. So we have, I didn't get that right. Okay, let's skip that. We see here that in the tunes list, I list more attributes from in the main presentation here, and this is done using the preview definition, where I define what should be used in the preview presentation in the user interface, where I list the different fields that I'm using, or I want to use or display in my presentation of the tune type. And then I have a function, a prepare function, where I can build up again a JavaScript object consisting of title and subtitle, and then I just do some string concatenations of the fields here, and then I get this presentation in my overview. So underlying all of this, there's a database, and they have developed their own query language. They call it GROQ. Again, it's JavaScript based. So let's have a look at how we can write GROQ queries. The most basic query is star, that give me all the documents in the database. And we can see here right now I have 524 documents in my database. If we want to constrain that a bit, we use the square brackets like this. Now I'm constraining the result to just document of type tune. And we can run that, and we should see that we get fewer items back. And yes, we get 14 documents back. We can even further constrain this. Let's say I want to do a kind of join operation. So I want to now get all tunes that have in their list of references to recipe document, they have at least one document with the name stone scale oil. So this is how we do a kind of joins in, and there I got something wrong. Yep, I'm missing a tick there, and then we got our query, and we can see we have three tunes in my document database that has this stone scale recipe. But we get a lot of different fields back here, also system-defined fields, these created at for the document and so on. And we may not want that, so we can then do a projection and select only the names. I add then or define the projection as a JavaScript object with the name. That's the name it will get in the result, and I want to pick the field that has the title name. And then we can see we have limited our list to just 3 items and the names of these crafters. And we can do similarly here. We can also display fields from other objects. So let me then also display their recipes. But as we saw earlier, the recipes is a reference to another document type. So we only get that reference initially. But if we then dereference that reference using the arrow operator, we can then go into the related documents and pick out attributes from that document. So now I'm picking out just the recipe name from the referenced document, and we get a list of the crafters and with a list of the names of the recipes that these crafters can make. So let's go back to the presentation. Okay, so we have seen that Sanity helps us go fast, but is it cheap? You can certainly start out cheap. I'm using the standard plan, which includes 3 users of the management studio, which is enough for me, and the request quotas on the API are quite sufficient. But of course, as your requirement increases, the price goes up, as can be expected from a commercial product. Sanity is built and marketed as a CMS, not as a database. The lines get kind of blurry when we talk about a query language and doing joins of related data and so on. But to be clear, I'm not advocating for dropping all your databases and use Sanity for everything. In my opinion, it is best used for your own content that you want to display on, be it a web page, mobile or any platform, but content that you own and want to display to the world. I would not store transactional data or something like that in Sanity. I don't think that would make much sense. It should be used where it fits, and it is a CMS at heart. You should also keep in mind that access control is limited in the free plan. You can define your dataset as public, and that means it's open for read for everyone, or private. But then you need a special token to access the data, and everything becomes private. in the more advanced plans, there are more options, but it all depends on your requirements. So, the user interface. We were already using Discord. The guildies already have an account there and use it for both text and voice communication. And Discord, like most chat systems, can be extended with bots that can provide all kinds of functionality. A Discord bot provides the user with a command line interface immediately available to all the users of my Discord server. There is no need to ask them to install anything. A bot is simply an application that once registered and authorized with Discord and on your Discord server, then it can listen for certain keywords in the text chat. When it sees a trigger word, it will pass the text, do some processing, and send a reply that will appear in the text chat. The processing the bot does can be as smart or as dumb as you want. The name bot may lead to thoughts of very advanced AI and such, but a chatbot is really just something that can accept commands and produce some response. It's entirely up to you to define or to implement any smartness in your bot. In my example here, I have a command crafting and the argument stone scale. This is then sent to the bot that will do its thing. In my case, it will go to Sanity and do some lookup on the data store there, and then build a reply that is then sent back to the Discord channel where it was sent from, and give a reply with, in my case, who can make this stone scale oil. And we see here we had the same three tunes that we saw earlier. So my building blocks are now Discord, where the user enters their command, which is then sent to my bot that goes to Sanity and looks up the requested information for the user and display the result in the Discord chat. Discord has a very detailed and good documentation on their REST API, but they have OAuth endpoints that can be used for authentication, and there are a lot of features available directly through their HTTP API. But as mentioned, I wanted to go fast, and I prefer to use the higher level NuGet package, discord.net, which is a very nice library that builds on top of the raw API. It makes developing a record bot just as easy as developing a regular .NET Web API controller. In fact, the programming model is very similar, as we shall see. To do queries against the Sanity API, we use another NuGet package, Sanity Client. The package is written by myself. It is a .NET client that takes care of all the details of sending a query to Sanity and to do the JSON deserialize the return JSON documents into regular .NET classes. Let's have a look at what the bot implemented using Discord.net with queries in Sanity looks like. So here I have my bot application where it's just a .NET Core console application with many of the features that all who knows and are used to .NET Core development will recognize quite immediately. In this case, I start with registering all my types into my into the .NET Core dependency injection mechanism. We don't have to use dependency injection, but I like using it, so I'm using it here, calling this configure services method, where which we can see down here below, and it creates a service collection, which we know from .NET Core development otherwise, and call registered services, and then finally builds the service provider. Let's have a look at this registered services so we can see the types that I'm registering here in my bot. I start out by calling the extension method on the Sanity client to register my Sanity database. It needs a project ID and a dataset and a token to identify the correct connection to my Sanity database. Then I add the Discord classes. First we have some standard library classes, and then finally the command handler, which we will look into in just a second. And then I will add different repositories and a query, which will then use the Sanity client that we registered to do the queries and get data from Sanity. So let's head back first to our main, and we have then registered our types, and we do then immediately we resolve the Discord client, set up some logging, and I do an initialization of my recipe repository, and then we do the login towards the Discord API. You can see here I read from my configuration a bot token. When you start developing Discord bot, you first need to go to the Discord pages and fill out some registration of your bot. Anyone who has done any work on OAuth will probably recognize this. You put in your name, you enter what permission the bot should ask for when it is authorized in a Discord server, and you get back a client ID and you get back this bot token that will be used as an identifier, and it's very important that you keep this bot token very secret, because if someone else can get to it, then they can impersonate your bot. Then we start the client, which will then connect to the Discord servers, and I have a little output here to the log. I will explain later in the presentation what we are doing here with this log line. And then finally we call the install command async on the command handler, which was the third class we registered for Discord. Here we simply set up the function. This is the main command handler for my bot. So we set up the function that should be called by the library whenever there's an incoming command from the Discord into my bot. And then I call the add modules async. This will do auto discovery of all the modules in my application. Modules can be compared to anyone who knows any .NET Web API controller development, and a controller and a module is very much the same or similar concepts. For each of the command handling function, it's more or less boilerplate code. I define here that I'm looking for anything that starts with a bang. So my commands should start with a bang so that I don't pick up on normal chat. If the command starts with a bang and then followed by my keywords, I will match it and reply and try to reply to it. And then we just call the command. And as I said, we have these modules. A module is something that inherits from module base, and that makes it discoverable by the auto discovery that we started earlier here. Each of my modules should have a group attribute defining the main verb that we are triggering on, or the main word we are triggering on. So my bot here will trigger on bang crafter, and then it will try to match any of my command methods down below here. Here, each of the command methods is identified by this command attribute, and they can then have different arguments. And the discord.net library will do something similar to model binding from controller APIs, and map any and do the mapped typing, or map strings to string arguments, numbers to numbers, and so on. It has a support for a number of different data types, and it will try to call the function that most closely match whatever the user typed into the user interface. I have a breakpoint here in each of my command methods. So if we then quickly start the debugger, we see here that it's starting up. Just a second and it will be running, and it says it is ready. So then I go into the Discord application. I have different Discord servers. A Discord server is similar, if you know Slack, it's similar to a workspace in Slack. It's more or less the same thing. And in my Discord server here, I have installed the bot and authorized it to listen to these commands. So I type crafter of stone scale and hit enter, and we should then see, yes, it then will match because I typed crafter recipe, it will, or the recipe name, it will match with the first method here. Do some simple argument validation, and then we do a query against the Sanity API, and from the result from Sanity we build a text response that is then sent back to the channel where I type my command. So we got back the following: craft stone scale oil. I did some mapping here. I read stone scale, and then I will look up in the available recipes and find that stone scale oil is the one matching, or most closely matching stone scale. And then I get the names of the crafters that can make me this stone scale oil. Same if I here type crafter, I misspelled that, crafter stone scale and 1, 2, 3, so I have a number. Then it should break on the other method, because it has done this model binding and found that there are two arguments, a recipe stone scale and the number 1, 2, 3, and it will simply here just echo back the text or the values that I entered. So it will reply, well, you sent the recipe stone scale and number 1, 2, 3. So we have seen that developing a user interface using Discord client is very, very fast. There's very little code that we actually have to write. We can focus solely on the business logic. But is it cheap? Yes, definitely. It is as cheap as it can be. It's completely free. So we have a system consisting of Discord, a bot, and Sanity. Both Discord and Sanity are software as a service, and we don't have to worry about running them at all. They are running on either on Sanity or on Discord's servers. The guy in the middle, however, the bot, he needs somewhere to live. Kubernetes is my clear preference for running services these days. Yes, some knowledge is required and it may be overkill for the smallest systems. But going with Kubernetes, you know you have a platform that can grow with your needs. But wait, you said going fast and cheap. Yes. A couple of VMs are required to run a Kubernetes cluster, but as we shall see, it's not that bad. I have a MSDN subscription with included Azure credits, so choosing Azure was a no-brainer for me. There are many VM sizes on Azure to choose from, but I have picked a smallish but not too small VM, the B2S. I would not go too small because each node in a cluster there's a fixed amount of resources that will be used for the system itself. So on a small server, the percentage used for this gets bigger. Choosing the 4 gig sized B2S looked okay to me. I wanted to squeeze it into my monthly included credits, so I opted for 2 nodes in my cluster. The recommended, however, is at least 3. But, well, it's a hobby system and it seems well to work well enough with the 2 nodes. However, you should be aware that region matters. Both Beer and Azure VMs are expensive in Norway. So make sure to check prices in the region you have selected before you buy. Well, Kubernetes is a huge area that could easily fill the whole talk alone, but there's one particular area that I have used for my project that I find very useful and I would like to share with you. Operating systems have used the file and folder abstraction for other things than just plain files for a long time. By implementing a driver, we can use the file system abstraction for other things. We can implement a driver that let us read secrets from Azure keyvault as if it were local files on our disk. Each secret becomes a file in our file system, completely transparent to the application. Azure AD Pod Identity is another service we can install in our cluster. Using Azure AD Pod Identity, we can connect pods with managed identity and through this we can control the access rights for each pod to Azure resources, such as keyvault. So I can say that this pod, these white brownish pods, should have these access rights, and the blue one another set, and the green pod maybe should have no access to the keyvault at all. Combining the two, we can manage access to keyvault and provide the keys to the application running inside the pod, completely outside the scope of the application. This ensures that the administrator can be left to manage this and the developer does not have to do anything special in his or her code. To the developer, it makes no difference if the code is running on his or her laptop or in a Kubernetes cluster inside Azure. The required service for mounting of secrets in the file system is dependent on your Kubernetes version. If you are on version 1.15 or older, you would use keyvault flex volume. If you are on version 1.16 or newer, the one you want to use is Azure Keyvault Provider for Secret Store CSS driver. Let's see how we set up this. So we stop And here we can have a look at our deployment manifest for our bot pod. The part that where we define the integration with the keyvault is here down below on the volume mount. We specify a mount path. I want that the keyvault secrets should be present in the folder under the mount path kvmnt in this case, and I want a read-only file system. I would then define in my volumes section, I would then define that I'm using flex volume here in my pod. And I specify a driver, Azure/kv. I'm using a keyvault. My keyvault is named keyvault. My name is Midgard key. And then I list the different secrets inside this keyvault and the names of the secrets. So I want to have a file for the Discord token, one for Sanity token, and one for demo secret here inside my pod. And when I then deploy this to my cluster, it will mount from the keyvault and map the named secrets from the keyvault into the pod, and they will all be available under the path that we specified in the deployment file. So let's have a look at this. I have prepared some commands. First, I'm running kubectl get pod to list the pods inside my cluster. We can see here I have the Midgard bot pod running. Let me then do a kubectl exec, which will then run a command inside the pod and specify the pod name and then the command I want to run, which is ls to list the contents of the kvmnt folder. And this will now run inside my pod. If I can type the correct command there. So we see here down here in the terminal, I got the response back. And in fact, I have 3 files: the Sanity token file, the bot token file, and the demo secret file. Inside these files, we will now have the secrets from the keyvault. So I again run kubectl exec, name of the pod, and then run the cat command on the file demo secret inside the kvmnt folder. And we run that in our terminal down here. And we see that the contents of that file, and in fact my secret is, this is from the keyvault. So how do we then read these secrets in our application? And let's go back to the application here. And we use standard .NET Core configuration or we can use standard .NET configuration to read these secrets. The configuration system of .NET Core has a number of different extension methods that we can use to provide configuration sources for our application. In this case, I'm using add JSON file, which you probably know already, to add the app settings.json source. And I use user secrets that we will be using for local development, and environment variables, and finally I use the add key per file. And the add key per file is designed exactly for this purpose, I think, where it can then read the folder I specified, again the kvmnt folder, and read each of the files located in that folder will be available to the configuration system as a configuration setting. So now we know, or you may see why we had this console write line where we read from the configuration and read a demo secret and display that on startup of the application. Let's first look at how this would look when we do local development. I would then use .NET user secrets and set this demo secret to this is from user secret, so we can see the difference when running locally and when running inside the pod. So I set that setting, and I will start my my bot, which will then on startup type or write to the console the contents of the configuration setting. And not too surprisingly, it works to read from user secrets, and we see here demo secret is this is from user secrets. We can see then how the exact same code, when it's deployed to Kubernetes, will then use the last config source. It works, configuration works like that always the last configuration source is used if the same setting is in several places. So in the cluster, it will always use then the add key per file extension method if the secret is present on that value. So we can then use, if we go back here and to the terminal, and have a look at the logs of the running pod inside my cluster using kubectl logs and the name of the pod, and I pipe that into less so that I see the beginning of this log file, and it should then read demo secret, this is from the keyvault. So we see that the exact same application works without any modification to the application. It works when running locally, and it works inside Kubernetes without us having to write any special code that knows anything about keyvaults, Azure, Kubernetes, anything. It just use these very simple abstractions and reads from the file system, and the administrator, as long as he configures everything correctly for the application to run, everything will just work, and we have a very clean separation of concern. So, oops. If I can get back to the presentation there. Okay, so to summarize, for the UI I used Discord and bots, which is a quick way to get a user interface in place without getting distracted from the pure functionality. For the data we used Sanity, which automatically generates the management UI for us, saving us a lot of work, and it's really quick to get up once you know the tool. And for running the bot, we used Kubernetes that provides a great platform that allows for growth and mounted secrets, which is a great security feature, allowing us to keep our secrets really nice and safe inside keyvault, and while still allowing the developer to not have to worry about this. Thanks a lot for listening, and now we may have time for some questions. If you would like, you can then go to the Slack channel for conference room 1, and we can see, and I will try to answer any questions should there be any.